Hi everyone. In this video we'll take a look at an example of constructing a Turing machine. So let's take the language a to the power n, b to the power n, c to the power n, and here is the general procedure that we'll be following. Let's say we have a tape right here where I have a b, an a bb, and a cc, and a b again, and I can just write a b here as well, doesn't matter. So what I'm going to do is whenever I find the first a, I will change this to an x, then I will skip to the right until it's an a, and I will find the first b and change it to a y. Then I will skip left until I find the first c, which I'll change to a z, and then I'll keep going left till I find my x again, after which I will again start moving to the right by finding the first a, changing it to an x, and so on. So this is the general procedure that I'm following. So I'm marking all of my a's with x's, all of my b's with y's, and all of my z's with all of my c's with z's. And let me just warn you that that the Turing machine that we are going to be drawing is not going to be a very simple one. So let's start getting into it. So we first start with a state q0. So this is the state that we start with, and what we do is we uh, find an a and we move to a state q1. So this is when I find an a, I change the a to an x, and I move the cursor to the right. So this is my transition from Q0 to Q1. Q1 is where I'll be staying till I find the first B. So what I do is I say that if let me just get rid of this part right here. So what I'm saying is I stay at Q1 until I find a B. So as long as it's an A, change the A to an A itself, so don't change it at all and move to the right. Another additional rule that I have to add here is if I find a Y, then I want to keep it as a Y and move to the right. And the reason that could happen is let's say I have the tape like this. So I've marked my first A, and I just marked my second A right here, and the first B is already marked because it got changed to a Y when I changed the first A to an X, and I have the second B right here. So this B right here is the one that I want to skip to. So that's why I need this rule right here, which says that if I have a Y, then keep it as a Y and move to the right. The next thing that I want to do is if at Q1 I do find the B, then I go to state Q2. So I go to Q2 on a B, and I change the B to a Y. So I'm converting the B to a Y, and then I move right again. And Q2 is very similar to Q1, so I just stay at Q2 when I have as long as I have a B. So I change a B to a B itself, so no change there, move to the right. If I have a Z because I encountered a marked C, then keep the Z as Z itself and move to the right. So at Q2 I'm just moving to the right, and then I move to Q3 when I get a C, and I change the C to a Z and move to the right. So actually what I should be doing is after I mark the C to a Z, I should be moving left. So I move left from here, and what I do is from Q3 I want to skip till I find an X. So I'm going to stay at Q3 for quite a lot of transitions. So let me just decrease the size a bit for this so that I can actually add more states to it. So I'm going to stay at Q3 for multiple transitions. So I draw self loop on Q3, And what do I say? I say that as long as you're getting a Z, stay at Q3. So if I get a Z, keep the Z to Z itself, move to the left, stay on Q3. If you encounter a B, then keep the B as a B itself and stay on Q3 and move to the left. If you encounter a Y, then also stay at Q3. So change a Y to a Y itself, move to the left. Um, and if you encounter an A as well, just keep the A as an A and move to the left. So this is what I'm doing. This is what I'm staying at Q3 for. So that what happens is the following. So if I have a tape right here, and what I've done is I've marked my first A, I have my second A right here, I have my third A here, I have a I should have a Y actually, because I changed the B to a Y. Then I have my second B, I have my third B, and now what I did was I just converted the C to a Z, and now because I moved the pointer left over here, what I'm going to have is my pointer is right here. So what I'm saying is the following, that if I have a B right here, so the second rule on the self loop on Q3, so I have a B, move to the left, so move this here and stay on Q3. And if I have another B, just keep the B as itself, move to here, so I get a Y here. So I again keep the Y as Y itself, move here, and if I get an A as well, I'm staying at Q3. And the reason is because I want to get to the first A. So how do I find the first A? I do that by finding the X and then moving one step to the right. So that is exactly what we are going to be doing. So let me just get rid of this, and what I do is I say that when I find an X, I go again to Q0. So I do this right here. And when do I want to do this transition? This is when I have an X on my tape and I don't want to change the X itself, but I want to make a transition to the right. And then from Q0 I start my loop all over again. So when I get an A, I change it to an X, I move to the right, and so on. So now all we need to do is we need to add some kind of a finishing. We want to now check whether everything has been marked, and if everything actually has been marked, what's going to happen is from Q0 I'm going to move to a state, let's just say Q4. And when is this going to happen? If I get a Y at Q0, then this is going to happen. So I have a Y on my tape, I change it to a Y itself, and this time what I need to do is I want to move to the right. So I move to the next Y, or it could even be a Z. And what I do at Q4 is I keep going to the right. I keep going to the right as long as I find a Y or a Z. So I can just draw a self loop on Q4. So I draw a self loop on Q4. Let me just draw it like this. And what I'm saying is keep moving to the right as long as you're getting a Y. So change a Y to a Y. So meaning don't change the Y actually, and keep the Z as a Z, and once again move right. So this is what we are doing. And when do we go from Q4 to our actual final state? When we get a B, which is our blank tape symbol. So on a blank tape symbol, I move to my final state, which is, let's say, Q5. So this I do on a blank symbol, and I don't need to change the blank symbol to anything, and doesn't really matter what direction I move the cursor in, because I'm just moving to the final state. But because I just have to mention it, let me just say that it moves to the right. So this is the Turing machine that we have created to accept this language. I know this is not a simple Turing machine. There's a lot of transitions, and what we'll do in the next video is we'll take a couple of strings and try out this Turing machine. Before the next video, I'll probably draw a better version of this Turing machine on my uh, page, and then we'll start looking at a couple of examples. So I'll see you there. If you did understand some part of this at least, do give the video a like and hit the subscribe button if you haven't already. See you in the next video where we'll take a look at those examples.